Hi everyone. In this video, we'll try to analyze another important circuit used by operation amplifiers, which is the non-inverting amplifier. We did before the inverting amplifier. Now this is called non-inverting amplifier. So first, we will analyze this circuit, find the relationship between the output voltage and the input voltage, and then we'll do a little demonstration to show you the output voltage, how it's really, when it is measured, what is the value of that voltage. So this is our inverting amplifier. Now, basically, every op-amp, as we know, it has two terminals: input, the negative or the inverting input, and the non-inverting input. So in the inverting amplifier, basically your voltage input, Vs, is connected to the inverting terminal. And we found that your V out is basically equal to minus R2 over R1 times your Vs. So it is an amplifier with, this is the value of that, and inverting because of the negative sign. Now, how we can go from here to the non-inverting amplifier? So R2 stays the same, which is the feedback resistance, nothing changed, and always you will have the feedback from the output to the negative terminal, regardless if you have an inverting or non-inverting amplifier. Now here, the inverting terminal is connected through R1 to the ground, not to the input. So R1, I just take it to the ground here, and then the non-inverting terminal through R1, which we'll see that this R1 doesn't have much of applications or much of usage in ideal op-amp, but it's, when it comes to practical op-amp, we need to have something connected here. Then you will have here your Vs. So your input Vs is basically connected to the positive terminal. That is the basic difference between the two. Now we need to analyze the circuit. So we know that the op-amp, they have the two rules, that Vn is equal to Vp and In equal to Ip equal to 0. The question is, what is your Vp to find Vn? Now, since Ib is equal to 0, so the voltage drop across R1, the voltage here is equal to 0 as well. So it means if this voltage is equal to 0, then the voltage here, which is Vs, is the same at the node Vp after the resistance. So now these two will equal to Vs. So Vn here basically is equal to Vs. We will apply KCL now to find the relationship between V output and Vs. KCL at Vn node. Now we have here current directions. Here the current in the feedback resistance going into the node. Here is leaving the node. It doesn't really matter the directions as far as you apply the rules. Current enter the node equal to current leaves the node. So the current that enter the node here, it is V output minus your Vs divided by R2. This current leaves the node. So this is equal to Vs divided by R1. Now we will move Vs in one side, keep V out in another side. So this is V out divided by R2 equal to Vs over R2 plus Vs over R1. Take Vs as a common factor. So it becomes 1 over R2 plus 1 over R1. Let's multiply everything by R2. Then your V out is equal to Vs 1 plus R2 over R1. And this is the gain of your non-inverting amplifier, 1 plus R2 over R1. So now we'll go to the demonstration. What I will do, I will select my R2 equal to 10 kilo ohms, R1 is equal to 1 kilo ohms, and your Vs will equal to 0.6 volt. So if you apply these values, your V out, we expect to see 0.6 times 1 plus 10k over 1k, or 0.6 times 1 plus 10 0.6 times 11, which is equal to 6.6 volt. So that is the theoretical value of the voltage that we expect to see. Please come and join me, and let's go and try to demonstrate this circuit.
This is the circuit for the non-inverting amplifier. So compared to the inverting amplifier, we did the following modifications. First, at pin number 2, we have the input resistance, the 1 kilo ohm, now connected to the common point instead, or to the ground, instead of connected into the supply. On the other hand, pin number 3 here, as you can see it here, uh, it's connected to a resistance connected to the voltage supply. So we switched basically our input from the inverting input to the non-inverting input, or from pin number 2 to pin number 3. Now let's start to measure the voltage, and this is your V out. Of course, there is no voltage because basically there is no input. We do not connect the bias yet. Connect the bias here, and my input is 0.6, and we are expecting to get 6.6 volt, which is very close, 6.7. And notice here the sign of the output voltage is positive because this is a non-inverting amplifier.